Hello, it's James from xrobots.co.uk. Today we're going to be fitting the new Lulzbot MOARstruder to a Lulzbot TAZ6, and this extruder has a really fat nozzle for printing really big parts. You may remember seeing a preview of the MOARstruder in my vlog about the TCT show where I was exhibiting on the Lulzbot booth, so have a look back for that video. I do quite a lot of 3D printing in my channel and build quite a lot of big parts. I'm working on a large bipedal robot at the moment, and we also have Project Ultron and various other big robotics projects, so hopefully this is going to be really useful. But let's check out the differences between this extruder and the stock extruder that ships with the printer. The extruders on these printers come off extremely easily. There's just one cable and one screw we can undo. So we unplug that, undo the screw, and we should find that just comes off in one piece, and we can compare them. Here are the two extruders side by side. This is the stock extruder and this is the MOARstruder. They look very similar. There's some grey filament being used to print these, and all of these are open source, so you can download and 3D print the parts yourself and put one together. We'll have a look at that in a minute. You'll notice the heater block is much bigger on the MOARstruder because obviously it has to heat much more filament to shove it through a fatter nozzle. The only other major difference I've noticed here is an extra piece of plastic here to give some extra reinforcement to holding the motor on, which isn't on the stock extruder, but apart from that they're very similar. Lulzbot are an open source company and all their hardware and software is open source, so they have this great guide at ohai.lulzbot.com which stands for Open Hardware Assembly Instructions, and you can find out about how to put together everything, including the printers, how to fit all the accessories and so on, literally how to assemble the whole thing from scratch. So if you want to know how to actually assemble the extruder and you wanted to build one from scratch, it is open source. You could download all the 3D printed parts and get hold of all the other hardware. There is a complete guide here. It's rather long to assembling the entire extruder, or I guess if you had to strip it down for some reason or you wanted to modify it, then this guide would be extremely useful. So have a look at that. I'm not going to go through all of it now. We do have a guide, of course, for fitting the extruders to an existing printer, and it'll fit the TAZ5 and the TAZ6. And that's the guide I'm going to use today for installing the extruder and testing it. So essentially it goes on fairly easily with that one screw and the connector. We have a couple of things to do in Cura, including flashing the firmware for the printer, but that's all taken care of through a simple menu of adding the new extruder and clicking flash the firmware, and that's taken care of for us. So there we go, we're going to work through the guide, so let's get that extruder fitted and see what we can get out of it. Right, I've installed the extruder with its one connector and its one screw, so now it's time to get the latest version of Cura and flash the firmware. So go to lulzbot.com/Cura and you can get the Lulzbot edition of Cura for various platforms, including Linux, Windows and Mac. So the latest version at the time of recording is 21.03, which looks like this. So all we have to do is make sure we selected the TAZ6 or whichever printer you're installing it to on the menu, go to Machine Settings, change Toolhead, it's a single extruder, and we should find here now we have the option for the MOARstruder, so we can click on that and click Flash the Firmware, making sure of course you're plugged into the printer with a USB cable. I've connected my laptop up with this USB cable straight to the printer, and I'm going to click on that Flash Firmware button. And off it goes. And once it's done, the printer resets, and now everything should be fully functional. There is a section in the guide about reading a sticker on the back of the extruder with the E-steps written on, and this is the factory calibration for that extruder that you then enter into the front panel of the printer to modify the E-steps for the firmware, and this is the amount of stepper motor steps for each millimetre of filament. I don't have a sticker on mine because this is actually one of the final pre-production units, and in fact is the actual unit from TCT show that I took home afterwards, so I don't have the sticker, so I'm going to leave mine at the default. So we're going to use the recommended model for testing here, which is the Open Hardware logo spiral vase. So I've just selected first run from the material here in simple mode in Cura. We've selected T-glass. The recommendation is to do spiral vase, which will hollow out this model and just give us a shell. I'm also putting a brim on, although that's up to you whether you want to help stick that down to the bed. So if we now look in layer view, we can see the actual tool path. And we can see, of course, that should give us something entirely hollow that spirals all the way up. In this case, I'm going to click on the Save G-code icon and save the G-code out to an SD card, which I'm going to put into the printer. You can, of course, control the printer with Cura using the USB cable, but I prefer to use the LCD option. I've just heated up the nozzle and put the filament in, and I'm just purging that through to check it extrudes okay, but we can see that's an extremely fat extrusion coming out of that 1.2mm nozzle. Normally these printers ship with a PEI bed, which is good for printing lots of stuff on. It sticks really well when it's hot and the stuff comes off really well when it's cold. This one, in fact, I've removed the PEI because I was printing nylon and other materials, and I found they print straight on the glass better with a glue stick. In fact, the recommendation for T-glass is to use a glue stick on the PEI because it sticks so well that you can't get it off. So in fact, we're going to make do with a glue stick straight on the glass for this demo. You can use either a Yoo-hoo glue stick, this is Elmer's glue, which is more widely accessible in the US, or pretty much any water-based PVA glue, and obviously you can clean that off with water when you want to. So we're just going to put a load of glue stick in the middle of the bed there where the thing's going to print. And that should be absolutely fine. So now we can go and get that G-code on the SD card, which will auto heat up the bed, the nozzle, do the nozzle cleaning, the auto leveling, and go and print the item. I've got my file on the SD card, so now we can just go to print from SD, and we can go and select the file, and it should set the printer off. So the printer's now doing its auto nozzle cleaning on that little felt pad, and it will do the probing and auto leveling to make sure every print is perfect. There it goes, probing all four corners. Alright, so we are roughly 9 minutes into the print, but already 38% of the way through, and this printer can lay down 100 grams an hour, which is quite a lot. And obviously, as you can see, we're a fair way into the print there, and you can see really fat extrusions coming out of that nozzle. So even though it looks like it's printing pretty slow, look at the speed that extruder gear is going round. It is laying down an awful lot of filament awfully quickly. Okay, we're approaching 50% and only 19 minutes. We're at 65% and 28 minutes into the print. And that is the print finished, and it took 48 minutes. Oh, there we go. So here's the finished part. It's come out incredibly well. Obviously I probably could have done without the brim, although it helped the thing stand up. We could break that off, but it probably would have stuck to the bed just fine without it. The part is incredibly strong, and that's mainly owing to the fact the extrusions are so fat there's more to stick them together. And because the extrusions are so fat, we've got some great optical clarity there, pretty much I think the best you'll get out of T-glass really, if we shine a light through it, and that looks pretty good. The recommendation for Lulzbot is to only use low warpage materials with this extruder like PLA and PETG and so on. So obviously if you were printing large parts with a large extruder, you'd expect that they'd warp a lot if they were bigger, so ABS is probably out for those really big parts. However, I already print some sort of medium to large parts in ABS with not too many issues, so I'm really interested to know what happens if I do print in ABS. Will I get better strength on the layer bonding due to the increased extrusions? So I'm going to try a test piece in ABS. We're going to do the same piece on this printer with the MOARstruder and also on a stock TAZ6 with a 0.5mm nozzle. So we're just going to print a tall tower in ABS with all the build lines of course going that way, and then we can see how easily it breaks. Now there's no settings for ABS in Cura, only for PLA and other materials, so I've had to make them up, so I'm not sure what print quality I'm going to get, but it looks like it's printing okay so far. We're just over 9 minutes in and about 30% of the way through, so this is an 80mm tall tower. Both fans are actually running on the extruder here, and that's because the layer time is too low, so it cools the plastic, so it's not putting molten plastic on top of molten plastic and it doesn't get wobblier as it goes up. That's not going to do me any favours in terms of layer bonding, but it is mashing those layers together pretty well, so I think it's going to be pretty strong. This is up to 17 minutes so far, and we're nearly there, so it's phenomenally quicker if nothing else. So here's its counterpart. That's running on a TAZ6 of a 0.5mm nozzle in 0.25mm layer heights, and again 30% infill. So far that's been running for 1 hour and 12 minutes. So here are my two parts. This one is of course on the MOARstruder, which isn't excellent print quality, but it's probably alright for a mechanical part or something like that. Obviously, as I say, I need to tune up the settings really for ABS. This is the other one, which is of course much lower layer height, so it's much better quality on the TAZ6. But how strong are they? So first of all, we're going to break the one in the low layer height with the normal thin 0.5mm nozzle. I've got some hammers and things, so let's see what happens. Yep, that broke pretty easily with the small hammer. Here's the one printed with the MOARstruder. Gonna need a bigger hammer for that one though. Let's try this one. Oh, there we go, eventually. But it is definitely stronger, and you'll notice in fact it hasn't snapped completely across the layer lines. It's snapped vertically a little bit there as well. And of course, if we were to use some materials of even better layer bonding, like the ColourFab HT that I've been using for that bipedal robot project, that's incredibly good layer bonding. Also Taulman alloy I've been using for the gears in the exosuit, that's really good as well. We can make some really, really tough mechanical parts with the new MOARstruder. So whether you want to print cosmetic parts, large parts, or really strong parts, the MOARstruder looks like a really good option. I'm definitely going to be using this more in some of my projects in my channel, so don't forget to subscribe for more updates on those projects to see what I do with it. Alright, that's all for now.